Now let's look at solving rational inequalities. So in order to solve a rational inequality, the very first thing that you need to do is make sure that you have a single rational expression on one side of the inequality symbol and 0 on the other side. So you really want it to be a single fraction on one side. If it's not a single fraction, you're going to need to find the least common denominator and make it a single fraction. After you do that, you're going to set the numerator of the expression equal to 0, and you're also going to set the denominator of the expression equal to 0, and you're going to solve each. The real numbers that you obtain when you do these are going to be your boundary points, points that we're going to place on a number line. Once we've done that, we're going to draw our number line and place the boundary points on the line. That's going to break up our number line into sections. We have to then choose a test point from each one of those sections. Then we want to evaluate the expression at each one of the test points and determine if it makes the inequality statement false or if it makes it true. Your solution set is everywhere that your inequality statement is true. So let's take a look at examples here. So my very first example, example 4, is x minus 1 over x minus 4 is less than 0. So step 1 says to rewrite it so you have something alone on one side as a single fraction, 0 on the other side. Well, that's already done, so I don't need to do it. Step 2 says set that denominator and numerator equal to 0. Well, here's my numerator. It is x minus 1. I set that equal to 0 and I solve for x, and I get x is equal to 1. My denominator is x minus 4. I set that equal to 0 and I get x equal 4. Then I said that any real numbers that I get are going to go on that number line. They're going to be my boundary points. So then I place these numbers on the number line. So here's 1 and there's 4 on a number line. We determine the circles for those points by looking at our inequality symbol, but you have to note the denominator will always have an open circle. Our denominator is always going to have an open circle, but since this doesn't have an or equal to, we would know that both of them would get an open circles anyway. Now we need to choose a test point from each one of the sections. Well, I need to choose a test point between negative infinity and 1, 0 works. I need to choose a number between 1 and 4, 2, between 4 and positive infinity, 5. Then what I need to do is I need to plug these test points back into the inequality here and determine whether they make the statement true. So I need to know if when I'm plugging 0 in for x, so 0 minus 1 over 0 minus negative 4, if that's actually less than 0. Now I'm going to place a question mark because I'm checking. I don't know. So 0 minus 1 is just negative 1, 0 minus 4 is just negative 4, but the negative over negative cancels, so I have a positive 1/4. Is positive 1/4 less than 0? No, I'm not. That's a false statement. Do the same thing with the number 2. Plugging in 2. 2 minus 1 over 2 minus 4. Is that a number that's going to be less than 0? Again, I put a question mark because I'm not sure. Well, 2 minus 1 is 1, and 2 minus 4 is a negative 2. So this is the same as negative a half. Is negative a half less than 0? Yes, that is a true statement. Last one, do 5. So I have 5 minus 1 over 5 minus 4. Is that a number that's less than 0? Again, we're constantly plugging it back into our original inequality. Well, let's see. 4 over 1, is that less than 0? No, 4 is not smaller than 0, so that is false. The last step says that our solution set is going to be all the intervals where it's true. Well, where was the only interval that I had a true statement? Well, here at 2, so that means that only the numbers between 1 and 4 are solutions for this inequality. So I need to put the interval notation of this. Since it's open circles, it's parentheses, 1, comma, all the way to 4 with a parentheses. Let's do the next example, example 5. Same thing. Do I have my rational expression on one side, all is a single fraction, and 0 on the other side? I do. So then I set the numerator equal to 0 and I solve. So 2x plus 3 equals 0. Solving, I get that x is equal to negative 3 over 2. And since I'm putting this on a number line, I'm going to write it as negative 1.5 just to make it a little easier. Denominator, x plus 4 equals 0. I solve, I get x is equal to negative 4. So let's put those numbers on the number line. So I have negative 4, and I'm just going to put negative 1.5 here. So this is not drawn to scale. Now, what kind of circles do these get? Well, I have my or equal to, but remember, the denominator always is an open circle. So then my denominator always is an open circle. So the denominator, or negative 4, has to have an open circle, but negative 1.5, because I have the or equal to bar, can have a closed circle. And the reason that your denominator is always going to have an open circle is that you can't have 0 in the denominator. That would make it undefined. So the denominators will always have an open circle. Right? Well, this split me up into different sections. Let's pick a test point from each section. Between negative infinity and negative 4, I can choose negative 5. Between negative 4 and negative 1.5, I can choose negative 2. Between negative 1.5 and positive infinity, I can choose 0. And any number would work, but these are the numbers that I've chosen. Plug them back in to the original inequality here. Instead of x for the first one, I'm going to write negative 5. So 2 times negative 5 plus 3 over negative 5 plus 4, is this actually greater than or equal to 0? And again, I put a question mark because I'm checking. Well, 2 times negative 5 is negative 10 plus 3 over negative 5 plus 4 is negative 1. I'm still checking, so I'm going to continue to keep my question mark. Negative 10 plus 3 is negative 7 over negative 1. Negative 7 over negative 1, my two negatives cancel, and that leaves me with a positive 7. Is positive 7 greater than or equal to 0? Yes, that is a true statement. Let's look at the next test value to check. Now let's try negative 2. So we have 2 times negative 2 plus 3 over negative 2 plus 4, and we're trying to figure out, is this actually greater than or equal to 0? Going along, negative 4 plus 3 over, this becomes positive 2. I'm still checking, so I keep my question mark. Is this greater than or equal to 0? Well, negative 4 plus 3 is negative 1, so I get negative a half. Is negative 1/2 greater than or equal to 0? No, it's not, so this is a false statement. Last one to check is 0. So let's plug 0 into the inequality. 2 times 0 plus 3 over 0 plus 4. Is this a number that's greater than or equal to 0? Well, let's see here. 2 times 0 is just going to be 0, so I'm just going to be left with 3 in my numerator. 0 plus 4 is just going to be 4, so is 3/4 a number that is greater than or equal to 0? Yes, that is a true statement. So I have to shade everywhere that's true. So now, what is the interval notation of this picture? Well, the very left is shaded, so I go from negative infinity to negative 4 with a parentheses, and I union that with, here's negative 1.5 with a bracket, because if it's closed circle, I could have written negative 3/2 as well, all the way to positive infinity. And let's look at the last example in this section. I have x minus 2 over x plus 6 is less than 1. Well, do I have a single fraction on one side, 0 on the other side? I don't, so the first thing I need to do is get that in the correct format. So I subtract 1 from both sides. So subtracting 1, I get that x minus 2 over x plus 6 minus 1 is now equal to 0. Well, I need a common denominator. Put this over 1. What would the common denominator be? It would be x plus 6. So let's multiply top and bottom over here by x plus 6. So I get x minus 2 and then minus x minus 6 all over x plus 6 is less than 0. Clean up that numerator for me. My x's cancel and I'm left with negative 8 over x plus 6 is less than 0. Now am I a single fraction on one side, 0 on the other side? I am. Great. So the next thing I need to do is set the numerator equal to 0 and set the denominator equal to 0. Well, does negative 8 equal 0? No, so there is no number there that I can put on the number line. I just now look at the denominator. If I solve that, I get x is equal to negative 6. Let's put negative 6 on the number line. What kind of circle does negative 6 get? Well, since it's in the denominator, it's automatically going to get an open circle. So now I need something to the left of negative 6, negative 7 works, and to the right of negative 6, 0. Plug it back in, and I always suggest going back to the original inequality just in case you made mistakes anywhere. So plugging negative 7 in, I have negative 7 minus 2 over negative 7 plus 6, and I am trying to figure out, is this something that is less than 1? So negative 7 minus 2 is a negative 9 over negative 7 plus 6 is negative 1. Two negatives make a positive. Is 9 less than 1? No, that is a false statement. Next one, 0. 0 minus 2 over 0 plus 6. Is this a number that is smaller than 1? Well, 0 minus 2 is negative 2. 0 plus 6 is 6. Is negative 2/6 less than 1? Yes, it is. That is a true statement. So the only place that I can shade is off to the right of negative 6. So what is the interval notation for this? Because of the open circle, I write parentheses, negative 6, comma, infinity. That's it for rational and polynomial inequalities.